Okay, my friends, another day according to Roger. Well, what is it today according to Roger going to be speaking about? This is the University of Geneva in Switzerland. Now, I went there, well, I didn't actually go to there. I took a course online about particle physics there so that I could confront them with my information of the particles that we saw. And they were very, very nice to me. They saw it and they went, wow, this is interesting. How did you do this? I said, I focused the beams through a venturi. But we use light, and they're using protons, which is big, heavy, huge particles compared to ours. And then they're coming around and smashing them head on. And they're trying to hit them head on. And they claim it's like shooting two knitting needles across the ocean and having them hit head on. It's that unusual of an event. And they were just letting them go by and hoping they hit. Well, I said, no, you have to obviously focus them down so that they try to hit each other. Well, at that point, they were listening to me, and I said, can I get involved in this? And they said, no, we'll follow you on Facebook. So I said, I am a nobody. This is just something I've discovered. Will you look into this? And they said, we'll follow you on Facebook. And that was it. And then that was the end of that. Now, my model says that muon neutrinos and electron neutrinos gang up together and form what we always called an electron. Now they call it a gluon. There's all kind of new particles. But what I want to show you here is from University of Geneva. They were good. Now here she's saying, dear students, all right, she's coming up, she says, you're fortunate to study in a generalist university. Now, what is my university, Mud Fossil University? Generalist university. You have to do everything. If you don't do everything, you do nothing. Because then you say, oh, I don't know about that. You have to talk to so-and-so. Oh, I don't know about that. Because there's nothing that is not interconnected. She's in ethics, histories, humanities, all kinds of things. And I am too. All right, so she says that we're always seeking to understand, especially with those who we don't agree with. But we have to do it with civility, and that's not happening. They understand. These people were good. We gained height together. We learned a lot about ourselves, really did. We rode the storm. This is during the COVID days. They reinvented learning. They do all of these things, which I do too. They watched each other. The early detection of autism by video. All of these things are exactly what I am doing. They explain exoplanets to children at home. This is what they should be doing, is teaching the kids something real. This is all about COVID and how they worked through this, where a lot of other ones just closed down. Why do I exist? Why am I doing this? What is the purpose of life? This is a good school. However, I felt like I just didn't have a place there. So I turned to Stanford. I turned to everybody, but Stanford responded, but wasn't interested. All right, so I didn't get anywhere with University of Geneva, although they did follow my research, and then they did shut down the Large Hadron Collider and made it focus. I was really surprised to see that, and the tremendous amount of increase in power instantly, as soon as they turned it back on. It took 3 years, and I think it was like $950 million just for parts. We did this all for less than $500. All of this, and here's the particles they're looking for at CERN and Fermilab. These are the particles right here, and we did them from light, so we were way ahead of the game on this, way ahead. Now, and these are the things I sent to Stanford. I said, look at the light speed. It's accelerating. Light can accelerate. It is a particle, and a particle has a magnetic wave around, a field around it, which creates a wave. That's all it is. So, and then I'm showing him how these particles manifest. This is what's called a tau neutrino. These are photons, and here they break up into the electron and electron showers and the muons. And that's green is exactly identical to the red. Here's the green manifesting itself, and here's the tau of the green right there. Same as the red, identical. So the particles are the same. This is just a wave, and the wave is here, but the particle is back here. That's what's going on. There's a particle back here that is pushing a field, so the field has to go through it, which creates a wave. It's all it is, particle wave. They're right. I agree. No, I didn't get anywhere with Stanford either. He wasn't interested. So anyway, this was 2016. That's over 6 years ago, in the summer of 2016. And I went back and forth with them, and we got down to the bottom, and it says, he says, thank you for your emails. I'll look through your materials in my spare time. I am not rejecting your things, but I'm looking for rational explanations. Well, you know, because I showed him the mud fossils and stuff, and that probably freaked him out. But this was when I had this other channel, Mud Fossils. And I was showing about semiconductor fundamentals, and I mean, I understand this stuff intimately. I worked right through the semiconductor, how it all started about, all field effect transistors, Zener diodes, capacitance, Hall effect motors, field effect transistors, all of that stuff. I understand it intimately. I understand the PN junctions, positive, negative junctions, forward biases, reverse biases, rectifier circuits, all the push and pull of the electrons. Why? I understand this stuff. At this point, I'm going to tell you right now, if anybody can stand in front of me and discuss this, I think I can win. I think I can show my model is correct, and the standard model, it just doesn't work at all. It never did. I've known this since 1970. All right, this is this I put out in 6 years ago, and that was my old channel. I got destroyed. Academia absolutely destroyed me, so I had to close that channel. And I opened up Mud Fossil University, still destroyed me, so it didn't matter. Anyway, this guy was real nice. He said, oh, the guy's doing good. I'm back. I'm going to follow you and so forth. There's only 3 comments on the whole thing. Anyway, I sent this to all the people that were questioning my abilities. And I have plenty of paperwork to show, and I have showed it over and over. But I never paid anybody for a degree. Now, if I paid somebody for a degree, I wouldn't be able to say the things I'm saying because they wouldn't let me continue. They did the same thing to everybody that's ever stepped up. They tried to destroy him. And unless you somehow get on top of the pile, you're never going to get there. Once a guy's on top of the pile, he has to die before the next guy comes on and has anything to say. And it's just like Max Planck said, science advances one funeral at a time. All right, watch this. All right, now, I always get asked, well, why should you speak to this? How come you're qualified to talk about the things you talk about? And they relate to my background in the semiconductor industry. Now, I was field engineering manager for a large electronics company, global electronics company, and I supervised the first release of electronic equipment in the United States, literally the first ones that came in the country. And I had to make sure that they worked when they hit the field. Now, and these are the different types of semiconductors. I'm just showing you this is because crystals are what everything is made of. You're nothing more than a bag full of crystals, surrounded with crystals. When I say crystals, they're polar molecules. There's nothing but dipoles. Everything that's consists of a two atoms together, minimum, is a crystal. That's all there is to it. And everything virtually does consist that way unless it's in a laboratory or it's like an inert gas or something. Anyway, here's the key to this whole thing. Solid materials are classified by the way the atoms are arranged. That's where I go, to the atoms, because that's my background now, is to crystalline structure of semiconductors. That's what makes them work. And in your cell phone, everything that you own that is electronic now works with semiconductors, and I'll talk about that in a minute. Anyway, they're all classified by the way the atoms are arranged within that solid. All right, remember that, the way their atoms are arranged. They're the same atoms in the same solid can be 2 different things. Carbon is in your pencil and it is in your diamond ring. Same exact identical elemental stuff, it's in different crystalline form. Now, materials in which atoms are placed at random are called amorphous. They're just in a, all floating around together like a bag full of sand. Materials in which the atoms are placed in a highly ordered structure are called crystalline, and we all know what that is, crystals. All right. Now, then you go into polycrystalline materials, and materials with a high degree of short-range order and no long-range order. All right. Now, if you go into all this stuff, these Bravius lattices and all these different things, this is what creates the angularity in crystals. Right? That's why they have this formulas and all vectors and all this business. That doesn't mean anything. All you have to know is that crystals arrange themselves in molecules. Well, here, I'm going to show you something that I used to do. Now, I'm not showing this to brag, but this is what I used to do. This is the kind of stuff that I would work on to make sure that, the crystals were right, that they were doing, I just studied this kind of stuff. I didn't really actually need this for the stuff I was doing, but it related so deeply that I got so deep into it I couldn't stop. So that's just what it is. And I never did stop. And I found out that literally everything that's being taught about chemistry and geology and rocks and everything is just not correct. And I'm going to show you why I say it. And this is why I say I can speak to this. This is, and this book is not, this book is filled with this. It's not like one day I did this and that was the end of the day. And plus I have other books here full of formulas and things about different, heat reactions and, I'm pretty deep into this. So I think I can speak to this. I don't think anybody can speak against me about it. And I will speak to anybody about it. Now, not only that, that stuff was from 1968, 70s, in that area. This is the new stuff. And I'm working on right now to show my particle physics against what they consider to be the standard model. This is all that exists. That's it. That's all, the whole thing. All this stuff is nonsense. It's these two particles and attached in different ways. That's all. And this is why it really upsets these people, because I'm outside of their realm. If I was in their realm, I couldn't say these things. That's why there's never any progress. These are my claims. I have claims. And I can show my claims are valid by my actual research, not just some theoretical nonsense about the standard model. Okay, so in the midst of this, I can't remember when this happened, but I realized Don Lincoln from Fermilab had seen the same particles we saw in his collider. And I got a hold of him. That didn't work out either. So I'm through Geneva, Stanford. I went to all of them. I tried everyone. I talked to Cornell. I talked to all of them. And nobody was interested. They just not interested. Now, but I could see the same identical particles, and then we could see them here as photons. This is light. These are photons of light. And we had the green, we had the blue, we had the red, and here they are actually separating, doing exactly what they wanted to see. This is from Fermilab. Muon neutrino attached to the electron neutrino, which is the red and the black there, which is the black and the white, same thing. It's just this is just a colorized enhanced version of this so you can see it. It's the same thing. And this is what I put out in 2015. This goes back to 2015. You see what the title was? Light is dark energy and matter in the vacuum of space. That's all it is. These particles come from the sun. They come from every luminous source. They're not just nothing while they're in space. They are the dark matter right there. The black is the dark matter and dark energy. And it's heavy. It's heavy. And they say the same thing. It's exactly what he says. I'll show you the article in a second. But anyway, this is fission and fusion. And I think right here, we could collect free energy. Literally free. And change the whole world. And this is, like I say, this was 2015. I put this up. Hold on one second. All right, so here it is right here. This is Fermilab. It's identical, same particles. And They won't talk to me there. And they say, have you got a question? Have you got anything you want to talk about? And I said, yes, I do. And they said, no, don't talk to us. I said, well, why not? Because I'm showing the identical same particles, a fixed size, and the other one is a point particle, but it burns. And the fixed size one doesn't burn, it just knocks things over. This is where all the weight is. That's the dark matter, that's the dark energy. Smallest particle they can find when they smash things to bits. We see these coming out of our Venturi, or going into the Venturi and coming out. Not only does Fermilab Don Lincoln say that these are the particles, the smallest ones that exist, and I agree. They say there's a quantum foam, and I agree with that too. Empty space isn't empty. It's filled with these particles of light. I don't know what they're thinking. All right, these are the Higgs fields they're talking about, which is, they call it the God particle, which I'm going to explain to you, and I'm going to show them to you, because I can show them to you in vast quantities. We can create them all day long. Now, here's what they're saying about them. In an article from CERN, it compares this to a pencil standing on its tip, a symmetrical system suddenly tipping to a point in a preferred direction, destroying its symmetry as it goes, so it self-destructs. Higgs and his fellow physicists proposed that when the universe was born, it was filled with these Higgs fields. That's just all crazy stuff. But I can show you these fields, and they are like the tip of a pencil, and they do self-destruct as they become particles again. It says the field quickly, in just fractions of a second, finds a stable configuration. I will show you this happen. But this is the process that breaks the symmetry. This gives rise to the Brute-Engel-Hertz-Higgs mechanism, which grants mass to the W and Z bosons. And I am going to tell you right now, those are the only things that exist. Those are the only two things that exist in the whole universe. And the W boson is strictly a matter of spin rate. So it can be red, green, blue, yellow, orange. It does all different rates, and it's just faster to spin. Blue is really fast. Red is sort of just... But that's the only two particles that exist. They make everything there is. And everything there is a dipole. Or every nucleus, every atom, every molecule. So, and I'm saying that's what gives rise to the W and Z boson, is that Higgs field. You want to see them? Here they come. Okay, these are Higgs fields. These are the Higgs bosons. And we use them with light. So when they came through, you had this blistering white coming through the Venturi, just whiteness. And then the Higgs fields come as the white comes back to the black. Can I show that happening? Yes, I can. Here it is right here. This is the tip of these fields. You see it? The tip of these fields. Now, it's like a pencil point coming at us. All right? It's just like this little pencil point coming at us. And what happens is the tip of the pencil hits the black particles first, and they absorb the black into the white particle. And they go back to stability, just like a regular particle now. Before, it's 100% electron shower. No black whatsoever attached. They should be always continuously forever attached. The only way they can break apart is hitting them head on in an atom smasher or forcing the fields to crush each other. The same thing that happens when they hit head on. It's the field crush that makes these things split apart. I'm going to show you the light developing, a tau neutrino, a photon, muon, electron, sterile muon, sterile showers, and then this reconfiguration in the Higgs fields. All right, the green is identical to the red. It's just much more powerful. This is the tau, which has two blacks and one white. And then it turns into the photon. And then in a second here, it's going to explode, and the white is going to separate from the black. And the black will go around and reattach to the white almost instantaneously. All right, now this is the best shot I have of the progression of light into the Venturi. And the only reason you see these light particles is because of the concussion at the Venturi. There is also light particles filling everywhere else. You don't see them because they're not in direct concussion line. Why do we see them in direct concussion line? Because as they stack up, I'm sorry, I keep hitting this thing. As they stack up against the Venturi, it's push to shove. They bounce. So they're bouncing back at each other. So it comes in really hot, and then it sort of bounces back and forth at each other, and then they just explode trying to get through the Venturi. So you have a hot particle, you have a slowing down particle where we can actually see the photon, and then you have the dividing black and whites separate the muon and electron neutrino, and then they become showers. The white is a shower, and the black is the sterile muon. And then shortly thereafter, they come back together. All right, this is the actual event. The light itself is the pulsed red laser. As it approaches the Venturi, a Venturi forces atomization, means it's going to suck that particle out. Well, when it does, it starts to suck it forward. But then, because it's stacking up here, these fields bounce back at these. So it's going real fast here, and it becomes a tau neutrino, a heavy neutrino. It's a heavy, heavy neutrino. Then here, it becomes the photon, which is the two blacks and two whites together, like two little bar magnets, right? Like just like this. Then here, it starts to separate, and the blacks separate from the white. Here, it's 100% white, no black whatsoever. The blacks start to filter in on the side, and then they start to go all the way out, the whole distance here. They start to attach. You see them? Boom, 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 boom. They're all attaching. You see that whole row of them attaching? And the reason these things are spinning in these interference patterns is not because of overlap from a double slit. This is because the white ones push other white ones away. They don't want to be next to each other. That's why you have this white explosion. The black ones could not care less. They want to be together. They are gravity. They're the pullers. They're the suckers. They just only, and they're heavy as hell, and they can't get through here. And in addition, as they smash against this Venturi, whatever's in front of them is getting smashed, and it's getting squirted out through here like crazy. That's why atomization happens in a Venturi. It causes what they call atomization. It forces these particles to concuss so violently that they literally separate. That's what a Venturi does. Accelerates them, smashes their fields together, separates them, which is fission. Here we should be able to get free energy right there. Put in a solar collector right there and suck it down. And this is my background. I understand this very, very, very well. And there should be no reason we can't do this. I'm too old to get involved. So, why don't you do it, Roger? Why don't you just start this? Why don't you do this? Why don't you patent that? No. Why doesn't somebody else do their goddamn job? Okay, this is the whole thing. Pulsed red laser. It would never get any more intense than this. And they say luminosity is the whole thing about increasing energy. If you see the luminosity increase, you have increasing energy. If you increase the energy, you increase the power. If you increase the power, that means you got free energy. All right, you started with a certain power, it took 5 watts. You got 100 watts coming out of here. That means you got 95 watts more than you started with. You send back in here 5 watts. You got a whole batch of watts you can use to do whatever you want to do with them. Just like a solar collector. The panels, you put them up. And I have a little design here. Here it is right here. It's simple as this. Simple as that. You use this right here as this. You see it? That's it. Here you put a solar collector. If it works, it works. If it doesn't, you spend a week trying to figure it out. Doesn't work, you go home. You spend a couple of $100. You know, in a big laboratory. I need some engineers. I need some people that know what they're doing. And somebody that can put this together and get it assembled and get it out to the people. Because then you could carry these things around in your hand. Just like this. I've been showing this for years. If we could get this thing here working and it could go right in a box like this, the output power here is absolutely staggering. It should be hundreds and hundreds of times what we started with, literally. And I'm not kidding you. The luminosity here will knock your socks completely off from what it started with. P equals I times E. I is the number of electrons. That's not going to increase probably. P is the power. The number of electrons won't increase. But if this goes up through the roof, this is the energy. P equals I, the number of electrons, times the energy. Well, 1, say this is just 1, doesn't matter. If this went up from 10 to 10,000, now you got 1 times 10,000 instead of 1 times 10. So you got 10,000 power instead of 100 power, or whatever it would be. This is free energy. And this is how we could do it. Or at least try it. I'm not saying it's going to work. I don't know. I do not know. But I can tell you what, if you had this and you had a disaster or a fire or Ukraine or anything like that, or just taking down the power grids, they did this meatballs with their machine guns or whatever they did, everybody could have one of these in their home. You never have to worry about anything. You have all the free energy you want. You'd be able to grow plants, you'd be able to pump water, you'd be able to clean things. No energy, nothing dangerous, not a single bit of danger. This is it. Rodney did this for years. He never had any problem, although I haven't heard from him in a while. Now, anyway, this is your outlets, and these are 50, 60. It doesn't matter. Once you get it in here, you're regulated to do anything you want. AC, DC, high voltage, low voltage, high amperage, low amperage, anything you want. Once you get it in here, you're set to go. Run your cars, everything. You never have to get gas. You change the world overnight, literally, because this stuff is off the shelf. Lasers are everywhere. And when you see that luminosity, you have to understand how much increase of energy there is from what it started with. And all these little lines, I don't know if you can see those. That's reverse energy. See that? See how concussive that reverse energy is? That's coming backwards. And the only reason we can even see these other light particles, these are the light particles. The particle's right back here. The particle's right back here, wherever it is. We never would have seen that. It had a wave in front of it, just like this one. The particle's back here. This one's being pulled forward so we can see it glowing. These are being smashed back into so we see them glowing. It's always push to shove. Just like they're sending their particles, a whole chunk of them going this way and another chunk coming this way, and then they get all kind of crap flying everywhere. We don't have to do that. We're coming through our Venturi. We're going to pick them up. Well, you see, if you can't see this, I don't know what I can say. To tell me that nothing I'm saying is correct and just walk away, which is exactly what's happened up to this very day. And this could change the world overnight. So it's time to do something. I don't know how to do this. Get a hold of Congress. Have them do something correct for change. They're spending our money, billions and billions and billions of dollars, to do these research that is absolutely unnecessary, totally wrong. And they know it's wrong. Nobody's fighting me. They won't stand up in front of me. Not a single one of them will stand in front of me, because I have the evidence. They have no evidence. They have taken my research and used it to enhance their research, but they're using the wrong part. They're doing something head on. They're like hitting two big balls. All right, big heavy-duty bombers. Boom! And then they just glass flies everywhere. And they try to find the smallest little piece of glass. And they say, "Woo, look at this, we found this. It's a muon, and there's an electron neutrino." Yeah, we found them too. Only we squirted them through light. We don't have trash to pick through. We can just watch them. By the way, when I told them how to focus, this is what they did. Slicing through an LHC focusing magnet. This is what they just put in. Quadrupole magnets. Focus the proton beam and squeeze them so that more particles collide when the beams cross paths. Well, that's obvious, but they didn't do that. They never did that before. Listen to what it says. It says, bringing the beams into collision requires precision comparable to making two knitting needles hit head-on, launched from either side of the Atlantic Ocean. So they have to make them hit head-on. Well, I tell you what, we force everything into the Venturi. There's no way for them to hide. The problem is that to hit two magnetic fields head-on, normally they'll skim each other because the fields push away. It's called the Casimir effect. Fields will never let themselves hit head-on. Virtually never. That's the Casimir effect. they will always sort of glance off because the fields will interrupt each other as they approach. They're pushers. They push each other away. So to have them hit head on is a very unusual event, but not for us. We're just forcing them to smash into each other's field because they can't go anywhere else. You see this? This is the Casimir effect, and I don't think they understand. All it is two magnetic particles pushing their fields apart, identical to pushing a particle away from each other. You can't make them hit. They're going to do this. They're going to skim off each other. That's why hitting head on and then exploding the particle that was their big protons, yes, that's going to be very unusual for them. Not for us. We're starting with light, so all we have is the tiniest particles anyway. When they crush together, they split. It can't be unseen. All right, this is actually kind of funny because this goes back to 2014. Now, Don Lincoln here showed these particles in 2013. All right, now we picked them up, I guess probably 2015 or so. But here we are in 2014, and everybody's starting to realize the CMOS in these smartphones. They're smartphones. Well, CMOS is complementary metal oxide silicates. And what they do are, they put these little tiny bits of them in pixels. They're little boxes. And if they sense energy in that box, it turns on a signal that is stored as a bit, and then when it comes back, it comes as a picture. Now listen to this. I just got this from my buddy Pedro. Hold on. Okay, my outstanding friends, I am going to go into a little dissertation about my past experiences with everything, really, from when I started to learn electronics all the way through as I engaged with all these different universities and didn't come out with any satisfaction. And this is what we discovered was particles that make up light. And this is light. They're made from particles. And they do have a magnetic field that surrounds them, which creates a wave as it passes through the air. But we were also able to do, just as Fermilab shows, find these two particles from light, not from a collision of a whole batch of particles that just smash everywhere. We were able to funnel this through a Venturi. I'm going to show you all this in extreme detail. Now, it sounds like I'm bragging, but this is just what happened. And I tried to go into the realm of the University of Geneva and Fermilab and CERN and all these people. I talked to them all. And they saw the particles. They understand what I'm doing. But they are invested in huge equipment. They spent billions and probably trillions of dollars in all of this equipment. They don't want to abandon. It's obsolete. This is what does the job, is lasers. And now they realize it, and they have just upgraded. And I'll show you all the upgrades they did after I showed them. And I'm not kidding you. At University of Geneva, I went there. And I showed them how to focus and how to make the particles crash. But they're using head-on collisions. It's almost impossible to do that. It's almost impossible to do that. Like what they say is to hit them head-on is so fortunate as to be able to hit two knitting needles shot across the Atlantic Ocean and have them actually hit point to point. That's how perfectly in line they have to be, and that almost never happens, and it's because of the oh boy, there's a certain effect, and I show it later in the video. You'll see it. Anyway, this is going to be my experience with physics and the physics realm. And I have plenty, I know what I'm talking about, trust me. As you'll see, I'm going to brag a lot. So get ready. Roger's bragging.